Geobyte.
Dear students, now let us discuss the previous year questions for the most important and very easy unit, that is work, power and energy. Okay, from this unit also you can expect reasonable number of questions for the BITSAT. Okay, I hope all of you clearly understood all the theory concepts what we discussed for the work, power and energy. Understood or not? Yes. Then let us take the very first question. You try to read the question clearly to understand what it is given and what you are asked to find. Understanding the problem is very, very important for getting the correct answer. Okay. The question is asking like this. A force of F equal to zero point 0.5 newtons is applied on the lower block as shown in figure. Look at the force applied on the lower block maintaining 2 kg, upper block is maintaining 1 kg. The work done by the lower block on the upper block for a displacement of 3 meters of the upper block with respect to the ground. Upper block is moving a displacement of 3 meters with respect to ground. Then what is the work done by the lower block on the upper block? Let me write that point. Here force is given zero point 0.5 newtons. Work done by work done by work done by lower block on upper block equal to how much? For the displacement of the upper block with respect to ground is 3 meters. Here a displacement I can mark as S. S equal to 3 meters. And look at the acceleration due to gravity. Acceleration due to gravity is given 10 meter per second square. Okay. Now, first let us decide the maximum acceleration that can be maintained by the upper block, because there is a coefficient of friction. There is a friction between the upper block and lower block. Then maximum acceleration maintained by upper block, that is 1 kg block, is equal to, that I am marking as A max, equal to mu into G. Mu is given zero point 0.1, G 10, equal to 1 meter per second square. That is the maximum acceleration maintained by the upper block. Now let us decide the common acceleration maintained by the combined system when there is no relative motion between the upper block and lower block. The common acceleration. Listen carefully, I am trying to explain the each and every point. Common acceleration maintained by combined system without relative motion. Without relative motion. That common acceleration A equal to the force dividing by total mass, that is m1 plus m2. Total force is given zero point 0.5. M1 is 1 plus M2 2, equal to 0.5 by 3. It is in meter per second square. Now here you got the maximum acceleration is 1 meter per second square, whereas the combined acceleration is, right, 0.5 by 3. From this you can conclude that the common acceleration is less than maximum acceleration. Therefore there is no relative motion. There is no relative motion between A and B. Between A and B, right? A and B means upper block and lower block. There is no relative motion between two blocks. Let me write it. Between two blocks. between two blocks. Okay. Then let us decide the frictional force. Frictional force on upper block by lower block by lower block F equal to, right, F equal to M into A, F equal to M into A, F equal to M equal to. So what is the mass of the upper block? 1 into A acceleration is 5.5 by 3. 0.5 by 3. It is equal to 0.5 by 3. Therefore, work done by the lower block on upper block equal to frictional force multiplied by displacement. It is 0.5 by 3 into displacement is given 3. It is equal to zero point 0.5. Work done. It is energy. Energy unit is Newton meter or joule. That is the work done by the lower block on the upper block. Look at the options. Look at the options. Option B is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem. Look at this problem. It is asking like this. A pendulum of mass 1 kg and length L equal to 1 meter is released from the rest at an angle 60 degrees. It is given mass of the pendulum is 1 kilogram. The length of the pendulum, simple pendulum, 1 meter, is released from rest at an angle 60 degrees. Released from rest at an angle 60 degrees means it can be marked like this. This may be the fixer. With respect to vertical, let us mark the vertical. With respect to vertical, the block is available, the pendulum is available at an angle 60 degrees. 60 degrees, right? So the length of the pendulum is L. Then the power delivered by all the forces acting on the bob at an angle 30 degrees will be by the time it is released, right? By the time it is released, what is happening? Actually, it is releasing from rest. This bob is trying to move like this. This may be the instantaneous position of the bob. For that instantaneous position, the angle made with respect to vertical is 30 degrees. Then what you are asked to decide? You are asked to decide the power delivered by all the forces on the bob at an angle 30 degrees. Here power delivered, very simple, power delivered by forces on bob equal to m into g into v into cos original angle 60 degrees. mgv cos 60. That mass is given 1 kilogram. G acceleration due to gravity, g given 10 meter per second square. Then we need to decide the v value. V equal to what? V equal to root over 2 into g into h. That h to be decided. Look at the height of fall of bob. This is the height of fall of bob. This height to be decided, right? For that, let us take the bob with 60 degrees. Bob with 60 degrees. With respect to vertical, this is the bob, right? Here angle is 60 degrees. Let us mark the vertical height. Let this is the vertical height for that 60 degrees. Let that is S1. That S1 can be decided like this. S1 can be decided. This is the length equal to 1 meter. No? 1 meter. Cos 60 degrees equal to right, S1 by L1. From this S1 equal to, right, actually it is L only. You need not write L1 and L2 because length of the pendulum remains same. L into cos 60 degrees. Next, after a time t, it is coming to after a time t, this coming to this particular position. Okay, now this is the like a pendulum. Now this is the vertical height from the fixer. From the fixer I am marking. This is the S2. That S2 can be decided. That S2 can be decided. How can you decide the S2? This is the S2. This S2 again cos this angle equal to what? 30 degrees. This angle is 30 degrees. Cos 30 degrees equal to cos 30 degrees equal to S2 by S2 by length L. Length L. Let me write it clear. S2 by length L. From this S2 equal to L cos 30 degrees. Now this is the vertical distance traveled by the bob h. That h equal to what? Look at the h. h equal to s2 minus s1 is equal to L cos 30 minus L cos 60 degrees. So it is equal to write L outside, cos 30 degrees minus cos 60 degrees. L equal to 1 meter only. 1 into cos 30 root 3 by 2 minus cos 60 1 by 2 1 by 2 1 by 2. So it is equal to root 3 minus 1 by 2. Root 3 value is 1.73 minus 1 by 2. It is equal to 0.73 divided by 2 equal to 0.36 meters. That is the vertical distance traveled by the bob, right? 0.36 meters. By using that, you can decide the velocity. Velocity v equal to root over 2 into g10. H value we decided 0.36. Simplify this value. For getting, my calculator has shown, right, the v value 2.68 meter per second. That is the velocity. Then you substitute all values for getting the power. M equal to what? 1, G 10, V equal to 2.68 into cos 60 1 by 2. You simplify this value. Here it is 2 5 times 5 into 2.68. It is less than 15. Less than 15 means, look at the options. Less than 15, 13.4. 13 point. Simplify that one for getting the right power which is in watts is 13.4. There is the answer. Okay. So you simplify this value for getting the V equal to 2.68 approximately. Understood clearly? Yes. Similarly, let us take the another important problem. Look at this problem. Don't have the fear by looking the length of the problem. Sometimes the lengthy problem is very easy. You can complete the problem by one step or two steps. It is asking like this: an ideal massless spring. Look at the ideal massless spring. This is the massless spring. S can be compressed 1 meter by a force of 100 newtons. From that you can decide the stiffness of the spring. Stiffness of the spring K equal to force dividing by deflection. Force is 100, deflection is given 1 equal to 100. Unit is Newton per meter. Newton per meter is the unit of stiffness. The same spring is placed at the bottom of a frictionless inclined plane, inclined at 30 degrees to horizontal. This is the frictionless plane. Frictionless plane means we need not consider any friction effect between the block and plane. The inclination angle of the plane is 30 degrees with the horizontal. A 10 kg block M is released. Look at the M. Mass of the block is given 10 kilograms. Is released from rest at the top of the incline and is brought to rest momentarily after compression the spring by 2 meters. Okay. So G given, look at the G value, 10 meter per second square. What is the speed of the mass just before it touches the spring? You are asked to decide what is the speed of the mass m just before it is touching the spring. For that, let us take another slide. Here, no condition for otherwise energy balance equation. Energy balance equation. By the time the block is sliding down, it is losing both kinetic energy and potential energy. Kinetic energy half m into v square plus potential energy mg z mg z mgz or mgh, right? So by the time we are asked to decide what is the speed of the mass just before it touches the spring. By the time it is touching the spring, it is maintaining kinetic energy and potential energy. It must be equal to half into stiffness multiplied by x max, whole square. That x max I can decide like this. It is clearly given that the spring is, right, compressed by 2 meters. 2 meters. Let A be with the, let this one A be with the 2 meters. 2 meters, that is the spring compression. This is given 30 degrees. Then this is the Z value. That is the Z value. Z equal to what? Cos, not cos, sine, sine 30 degrees equal to Z by 2 meters. Then Z equal to 2 into sine 30. Sine 30 equal to 2 into sine 30, 1 by 2. It is equal to 1 meter. That is the Z value. This x max is nothing but maximum deflection. That maximum deflection is given 2 meters. Look at that one. Look at that. Look at that point. 10 kg block M is released from rest at the top of the incline and is brought to rest momentarily after compression the spring by 2 meters. That means the maximum deflection of the spring is 2 meters. Then it can be written like this. This V to be found. From this I can write that mv square mv square. Let me write it clearly. Otherwise, let us multiply with 2 on both sides. Here it is getting mv square plus 2mz equal to k x max whole square, right? That is dividing by m on both sides. V square plus mgz, mgz, 2mgz, right? It is 2gz equal to k by m into x max whole square. V square equal to k by mass into x max whole square minus 2gz. Then V square, let me write the k value. What is the k value? We have decided the k value 100. That is the stiffness. 100 by 10. 10 into maximum deflection is 2 square minus 2 into z into, right, what this is 2g into z equal to 1. It is equal to 10 times 10 times 10 into 4 40 minus 20. So v square equal to 20. From this I can write that v equal to root 20 meter per second. That is the answer. Look at the options. Root 20. Option A is absolutely correct. Understood clearly? I try to explain the each and every point at your understanding level. Okay, na? Similarly, let us take the another important problem. Okay, look at the screen. It is asking like this. A spherical ball of mass 20 kg is stationary at the top of a hill of height 100 meters. It rolls down a smooth surface to the ground, then climb up another hill of height 30 meters, and finally rolls down to a horizontally base at the height of 20 meters above the ground. The velocity attained by the ball is, let us take the smooth ground. Let the smooth ground. It is given that the spherical ball is available initially at the top of the hill of height 100 meters. 100 meters. It is rolling down to the smooth ground. Then it is climbing to the another hill, another hill of height 30 meters. 30 meters. Then it is reached to ground. Finally, it is climbing to another hill of height 20 meters. Finally, reaches to ground. This height is given 20 meters. 20 meters. Is it correct? So 100 meters, 30 meters. Finally, it reaches 20. Yes, absolutely correct. Mass of the mass of the spherical ball is given 20 kilograms. Okay. G not given. Let us assume G equal to 10 meter per second square. That is the assumption. Assume. Right. Now, for deciding the velocity of the ball, let us connect the conservation of energy law of conservation of energy, law of conservation of energy principle. Initially, the ball is maintaining potential energy, mass into G into potential energy with 100 meters is mgz. It must be equal to kinetic energy, that is half into m into v square, plus potential energy maintained right before it is coming to ground is with the third hill m into g into 20 meters. Okay. Now that is the energy balance equation. You can cancel the m on both sides. M on both sides, not g, m. M on both sides will be cancelled. Then g 10 into 100 equal to v square by 2 plus g 10 into 20. Let us simplify it. It is 1000 equal to v square by 2 plus 200. 1000 minus 200 is equal to v square by 2. 800 is equal to v square by 2. Then v square equal to 2 into 800, that is equal to 1600. Then v equal to root over 1600. Root 1600 equal to 40 meter per second. That is the velocity of the spherical ball. Okay, look at the options. Look at the option B. Option B is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem. Look at that problem. Asking like this. A particle of mass 2 kg is on a smooth horizontal table and moves in a circular path of radius 0.6 meters. Let us take the circular path maintained by the particle. Let us draw it clearly. This may be the circular path maintained by the particle. This is the radius of the particle, 0.6 meters. Okay. The height of the table from the ground is 0.8 meters. The height of the table from the ground, let this is the ground. The particle is maintaining circular motion on the table. That table is at a height of 0.8 meters from the ground. Okay. Now, if the angular speed of the particle is 12 radians per second, angular speed 12 radians per second. It is the angular velocity, not angular acceleration. Angular velocity radians per Second only. Second, the magnitude of its angular momentum about a point on the ground right under the center of the circle is. You're asked to decide the magnitude of its angular momentum. The magnitude of angular momentum is equal to m v r into sine of the angle between the radius of circular path and vertical line, that is 90 degrees. Sine 90. Sine 90 degrees. Here look at the r bar. This is the r bar. This r bar is equal to root over zero point 0.8 square plus zero point 0.6 square. It gives 1 meter. 1 meter. Okay. Now, but linear velocity v not given. Linear velocity v equal to what? Product of radius, right? This radius multiplied by the angular velocity. Radius is zero point 0.6 meters into angular velocity 12 equal to 12 into 0.6, 7.2, right? It is equal to m 2 into v equal to 7.2. The r bar is 1 meter. This is the r bar. And radius of the circular path I am marking as r. Okay, r. So here it is into 1 into sine 90 also 1. It is equal to 7.2 into 7.2 is equal to 14.4. Look at the units. Look at the units. Units are important. Mass. Mass is in kg. Velocity is in meter per second. Radius is in meters. Sine of the angle has no units. Then it is kg meter square per second. Kg meter square per second. That is the unit of what? Angular momentum. Look at the options. Look at the options. 14.4. Option A itself is absolutely correct. Are you following clearly? Yes. Similarly, let's take the another important problem. It is asking like this. A machine gun fires 300 bullets per minute. Number of bullets per minute equal to 300. If the mass of the each bullet is 10 grams, means 10 dividing by 1000 kilograms. And the velocity of the each bullet is given 600 meter per second. The power of the gun, very simple. Power of the gun equal to, right, kinetic energy of the all bullets per second. Right, kinetic energy of the each bullet, number of bullets multiplied by kinetic energy of the each bullet. A number of bullets are given per minute. That's why it should be divided with 60. Number of bullets per 60. Number of bullets n by 60. Kinetic energy of each bullet half into m into v square. Half mv square. Right. So let us take the another slide. Otherwise, let us substitute here. N equal to 300 divided by 60 into half into mass of the each bullet 10 by 1000 into v square. V equal to 600. 600 square means I can write 600 into 600. 600. Now you can cancel some quantities. 60 5 times. 5 times. Here 2 zeros and this 0 also cancelled. Final it is power p equal to here it is 5 into 1 by 2 into 600 into 6. It is equal to 6 to 300 times 5 into 6 30. 30 into 300, it is equal to 9000 watts. 9000 watts, but option is asking kilowatts. It by 9000 watts divided by 1000 for getting in kilowatts, that is equal to 9 kilowatts. Option B is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem. Look at this problem. A boy pushes a toy box 2 meters along the floor by means of a force. Force applied by the boy uh, on the toy box 10 newtons. The distance traveled by the toy box is 2 meters. Directed towards at an angle 60 degrees. Theta is given 60 degrees to the horizontal. The work done by the boy is, you're asked to decide work done by the boy, right? Work done equal to F S cos theta. Very simple. F is 10, S is 2, cos 60 degrees. Cos 60 degrees equal to 1 by 2. 10 into 2 into cos 61 by 2. This 2 to cancel. 10 joules. Work is a kind of energy. It is units is joules or Newton meter. Dear friends, remember 1 Newton meter equal to 1 joule. Okay. So look at the options. Option C is absolutely correct. Understood clearly? Yes.
Geobyte.